welcome to this video where we're going to look at measurement and conversion. In this section, we're going to apply some problem-solving strategies called USE, which is understand, solve, and explain. So anytime you're trying to solve some problems, we talked about in the previous chapter, Polya's four-step method. Here's another 3 steps that we can use when solving problems. The first one is to understand the problem, and the next step is to solve the problem, and then the third step is to explain your result. How far is a light year? So here we have in our question, how far, and how far refers to distance. So if I want to know how far a light year is, even if I don't know what a light year is, I need to know something about distance. And here you're provided with a formula which you could Google or look up, and that's distance equals speed times time. Okay, so what is a light year? A light year is the distance light travels in 1 year. So here again, I'm looking at distance. And if you look it up, light actually travels at 300,000 kilometers per second. Okay. So the problem is, this is in seconds, and we're looking at how far is a light year. So I want to know how far does it travel in 1 year? And here I'm given how far it travels in a second. So I need to use my formula here, which is speed times time is going to equal the distance. So we already know the speed, which is 300,000 kilometers per second. Per means, again, to divide. And I'm going to employ something called dimensional analysis. So I'm going to multiply by specific dimensions so that in the end, I'm left with the how far the light travels in a year. So I'm going to be left with kilometers, because kilometers is a unit that we use to measure distance. So somehow I need to cancel out seconds. Okay, so how would I do that? Well, since I'm looking at how far light travels in a year, I'm going to multiply by 1 year. And I still can't cancel years and seconds yet. So what do I know about a year? Well, I know that there's 365 days in 1 year. So that's going to allow me to cancel the years out. Now I need to somehow cancel days and seconds out. So what else do I know? Well, I know that in a day there's 24 hours. So I can cancel the days out. I'm getting closer and closer. Okay, I also know that there's 60 minutes in 1 hour, so the hours will cancel out. And then I know that there's 60 seconds in 1 minute. And the reason I put the seconds on top is because I need to cancel it with this over here. So the seconds will cancel, and then all I need to do is just multiply straight across now. 300,000 times 365 times 24 times 60 times 60. And when you do that, you get this number. And it's in kilometers, which is what we wanted. So that is about 9.46 trillion kilometers is how far light travels in a year. So try wrapping your brain around that. So what we used there was a method called dimensional analysis or unit analysis. And we learned before that units describe what quantity measures or counts. So unit analysis to analyze is a process of working with the units to help solve problems. We talked about or heard the words per and of. And we know that per means basically for every, right? So, let's say there's a class of 20 students and two of them are boys. You could say there's two boys for every 20, for every 18 girls. Okay. And for every means to divide. And then of is to multiply. Okay, here's an example. We're going to apply the USE, three-step problem-solving process. We're not actually going to write out the understand, the solve, the explain, but we need to keep those things in mind when we're solving problems. So here the question is, you're buying 30 acres of farmland at a price of $12,000 per acre. What is the total cost? So since I'm looking for total cost, I know that my answer needs to be in dollars. Okay, so if I'm going to start out with what I'm given, which is 30 acres, and I know that it's $12,000 and then per acre. Remember, per means to divide, so per acre. Now the acres will cancel, and then all you need to do is multiply 3 times 12, which is 36, and then there's 1, 2, 3, 4 zeros. So I'm going to tack those on. So what this means is that if we found that purchasing 30 acres of farmland at $12,000, it's going to cost a total of $360,000. What if a car travels 25 miles every half hour? How fast is it going? Okay, so how fast means speed. So we're looking for speed. Speed can be measured in miles per hour, kilometers per hour, meters per second. So what do I know here is that the car is traveling 25 miles every half hour, right? So every 1/2 hour. So I'm going to divide that by 1/2 hours. And when we divide, it's the same thing as multiplying by the reciprocal. So I'm going to multiply by 2 over 1 hour. And 25 times 2 gives me 50 miles on the top per hour. So my answer, you may see it written as 50 miles per hour. So what that means is a car covers a distance of 25 miles in a half hour, traveling at a speed of 50 miles per hour. We're going to be dealing with units that sometimes are squared or cubed. One of those instances is when we're dealing with area, okay, the area of a figure. Let's say we had a square, and let's say that, or actually let's make it a rectangle. Okay, and let's say that I had 4 feet for my length and 3 feet for my width. So if I wanted to find the area, it's the amount of space inside the figure. Okay, and how do I do that? Here I would do the length times the width. So here you're dealing with 4 feet times 3 feet. Well, I know 4 times 3 is 12, but what's feet times feet? It would be feet squared. Or you may see it written as 12 square feet. Now, I could also, when I'm dealing with volume, end up with cubes. So let's take that same rectangle and we'll make a rectangular prism. Okay. So we're going to pretend here's our 4 feet for our length, 3 feet for our width, and then we have, let's say, a height of 2 feet. So to find the volume, it's the amount of space inside a 3-dimensional figure. So if that was a box, in other words, like how much could I fit inside that box? So to find that, I would multiply the length times the width times the height. And I can easily multiply 4 times 3 times 2. That gives me 24. But then what's feet times feet times feet? Well, feet times feet is feet squared. So if I add another foot in there, I get feet cubed. Or you could say 24 cubic feet. And sometimes we're going to have to convert from regular linear units like feet or yards to square feet or cubic feet and so on. Let's identify the units that we're using here first. So then we know it's helpful if we're using unit analysis to figure out what we're going to need to end up with. So for instance, like when I was doing these problems above, I know that my units were in acres and dollars, and I'm looking for what's the total cost. So total cost, I know my unit should be in dollars. And here when it says how fast is it going, it's talking about speed, and speed is measured in miles per hour, kilometers per hour, meters per second. So here I have miles, and then I'm told every half hour. So I know my answer is going to be in miles per hour. So here, the price you paid for gasoline, found by dividing its total cost in dollars by the number of gallons of gas that you bought. So here I have, it's telling me specifically, I'm taking dollars divided by gallons of gas. So that's just dollars per gallon. Okay, and we would read it as dollars per, right? Per means divide, or for every gallon. So it's going to be so many dollars for each gallon of gas that you purchase. I'm going to let you do the check your understanding, and if you have questions, please feel free to reach out. So we can use unit analysis as a problem-solving aid. Okay, you generally cannot add or subtract numbers with different units, but you can combine different units by multiplying, dividing, and raising the powers. Okay, always perform all operations on both the numbers and their associated units, as we did in these problems here. So not only did we multiply 4 times 3, we also multiplied the units together and ended up with feet squared. So here's some keywords that will help you identify appropriate operations. Per, we talked about as division. Of, we know as multiplication. Square is raising to a second power, and cube or cubic is raising to a third power. It's easier to keep track of units if you replace division with multiplication, right? Dividing is just multiplying by a reciprocal. So, for example, instead of dividing by 60 seconds per minute, you would multiply by 1 minute over 60 seconds. It's just the reciprocal of this. When you complete your calculations, make sure that your answer has the units that you expected. If it doesn't, you've done something wrong. Okay, so in this next example, how many crates do you need to hold 2,000 apples if each crate holds 40 apples? All right, so again, I'm going to identify the question. It says, how many crates do you need? So my answer is going to be labeled in crates. And I'm told that I have 2,000 apples. Okay, and it says each crate holds 40 apples. So I'm going to divide by 40 apples per crate. And remember that dividing is the same thing as multiplying by the reciprocal. So here I'm going to multiply by 1 crate over 40 apples. And as you can see, the apples cancel, and we get 2,000 times 1, which is just 2,000, divided by 40. I can cancel those zeros out, and I know 200 divided by 4 is 50, and I'm left with crates. So you would need 50 crates to hold 2,000 apples if each crate holds 40 apples. Let's talk about unit conversions next. So a unit conversion is an important use of unit analysis. And that's to convert from one unit to another. So an example could be like, maybe I want to convert from kilometers to miles. Or maybe I'm baking something and I have to convert quarts to cups. We can use what we call conversion factors to do this. So an example of conversion factors are, there's 12 inches in 1 foot. Or there's 100 centimeters in 1 meter. Now remember, we can also write 12 inches equals a foot as 12 inches per 1 foot. Okay, or I could write it as 1 foot for every 12 inches. Both of those equal 1. They mean the same thing. 12 inches and a foot are the same. So anytime you divide a number by itself, you get 1. So really, you are going to be multiplying or using that when we're doing unit conversions in unit analysis. We're going to be multiplying by 1 in disguise. So if I wanted to convert a length of 102 inches to feet, well, I know that there's 12 inches in a foot. But in order to cancel out the inches, I need to put the inches part on the bottom so that these will cross out, and then 1 foot up top. And now you're left with the units that you need in the end, which is feet. So we're just going to multiply straight across, 102 times 1, and then divide it by 12, and my answer is in feet. So when I divide 102 by 12, I get 8.5. So 102 inches is 8.5 feet. Let's say you want to carpet a room that measures 10 feet by 12 feet, making an area of 120 square feet. But carpet is usually sold by the square yard. How many square yards of carpet do you need? Okay, well, I know that 1 square yard, if I break it down, is really just 1 yard times 1 yard. Just like in an earlier example, square feet was 1 foot times 1 foot. So it's a square that's 1 yard by 1 yard. Well, I also know that there's 3 feet in a yard. So really this is just 3 feet times 3 feet. And 3 times 3 is 9, and feet times feet is feet squared. So now I have a conversion. I know that 1 square yard is actually just 9 square feet. Okay, so now I need to take this 120 square feet and I need to convert it to square yards. Well, now it's easy because I know that 1 square yard is actually 9 square feet. So now the square feet are just going to cancel out, and I would just go straight across. I would get 120 divided by 9, and that's going to give me 13.3. So it's going to be approximately equal to 13.3 square yards. So all you need to remember is that 1 square yard equals 9 feet squared, and you can figure that out using unit analysis. Here's another example where we use unit analysis when we're dealing with currency conversions. So here we have the currency. We've got British pounds, Canadian dollars, and so on. This column represents dollars per foreign amount, foreign currency. So we're going to use this column to convert to US dollars. And then the last column is foreign currency per US dollar. So here we're going to use this to convert to foreign currency. Okay, currency is, by the way, just a country's money. So at a French department store, the price for a pair of jeans is 85 euros. What is the price in US dollars? Use the exchange rates in table 2.1 on the previous page. So let's say you're traveling in France and you see a pair of jeans that's 85 euros. How much money would that be in US dollars? Well, if I look back at my table, I know that 1 euro is equal to $1.225. Okay, so if I want to convert now, I've got 85 euros, and then I'm going to use this as my conversion. So in order for the euros to cancel, I need to put the euro, 1 euro on the bottom. And on the top, I'm going to have $1.225. And now the euros cancel, and if I multiply straight across, 85 times 1.225 is $104.13. So a pair of jeans that's 85 euros in France would actually be $104.13 US. And that is the end of this video. You can try the rest on your own. If you have any questions, please reach out. I will be happy to assist. Have a great day, everyone.